Welcome to the fireside chat session in the stream Global Manufacturing with the illustrious name Scaling Green Manufacturing, the role of digital twin and AI in the reduction of our carbon footprint. We have a full house today, so it's time to start. I'm very glad to have three very knowledgeable speakers to this subject here in the room with me. Let me introduce to you Nadim Jalbout. He is Senior Project Manager at Siemens Advanta, which is the consultancy technology pushing part of Siemens. Next to him is sitting Mr. Spiros Kouvelis, who is the director of EPLO, the Institute for Sustainable Development. And next to him is Emanuela Girardi, who is the president of ADRA, which is the AI Data Robotics Association established in Brussels. Looking at this topic, so it's like we have digital twinning, AI, and then sustainable development or carbon footprint. We put them into the same corner. There's a lot to cover here. I think it's obvious that digital twinning, it's modeling. Any modeling saves resources, saves energy, and is good for the reduction of our carbon footprint. But there's more going on. And especially with the recent advent of artificial intelligence, there's a revolution going on. And we have to see how that works out in today's manufacturing world and how governments should react to that. And then what impact it has on the environment, on sustainable development. I would first like to, especially for those who are not into digital twinning, I would like to get a bit of a historical overview. Nadil, could you help us understand what digital twinning is, when it started, and what changed to it with the entry of AI as we have come to know it in the last couple of years?
Thank you, Roland, and it's such a pleasure to be with all of you here today. Thank you. Digital twins are not a new concept, and they have actually started in the 1960s by NASA to create this concept to look into the exploratory missions when they started their vessels and to go into space. Fast forward to 1985, the concept of digital twins and modeling applied to the manufacturing sector.
Nadim, yeah, just one thing is important. Please try to speak as much as possible in the microphone. Ignore me. Ignore me.
So, 1985, we are talking about application of the digital twin concepts in a manufacturing setup. That started by the work of Dr. Michael Greaves and the University of Michigan, and they took it forward. So we move forward beyond 1985 to 2000s, where we started to develop the product simulation, product design along the full life cycle of the journey itself. And that's where the advent and the pervasive views of the PLM software, the product lifecycle management software, came about. Now, beyond the 2000s, something very interesting started to happen. Software started to improve, but also hardware capabilities started to improve, which are particularly on the IoT sensors. Their costs went down, their capabilities went up. Networking, cloud became very prevalent. And that's where it evolved to the digital twin that we know and hear of today. So what is actually the digital twin we're talking about? That's a good point. So the digital twin is a virtual representation of the physical object that we see in a virtual environment. It allows us to simulate and adjust different inputs and different outputs so that we can better design products and processes and factories themselves. As the evolution continues to progress at a very significant speed, we also see that the industrial metaverse is the next step in this direction. So what does the industrial metaverse? The industrial metaverse will allow us to experience the digital twin and its full capabilities, with the ability to have immersion, so being inside a virtual environment, the ability to interact with the different digital assets, as well as to collaborate with different organizations to produce new products and innovate faster. Imagine building ships, imagine Formula One racing, if you would like. How can we optimize? How can we produce to the best possible way so that we can gain this tiny margin and we can build faster and innovate faster?
All right. What would you say is what is in this revolution that we have seen over the past 2 years? I would say the start of ChatGPT. Everybody has seen it. What does that mean for individual companies, large companies, small companies? No, and please connect it. Let's connect it to digital twinning. So it's
Sure.
about manufacturing companies.
Of course. So as we go forward, the digital twins will keep improving and improving. So the capabilities that we add on top of it, like AI, basically would help into structuring the inputs that would go into this digital twin software, and would also help synthesize the outputs very quickly compared to previous models of this software. For example, the ability to process simulations can go up to 1,000 times more with the advent of AI versus what we currently have in the capabilities of the digital twins of today. And that's a game changer, because then you can run millions and millions of scenarios in a shorter span of time so that you are able to generate and innovate products faster, go to the market, be more competitive, and push forward the boundaries of manufacturing and what is possible today.
All right. So we always know a model is a depiction of the reality, but it's never the perfect reality. With AI, as I understand, we can get very close to the reality, but there's still limitations. And here I'd like to move to Emanuele, who advises the European Union on how to develop legislation. Perhaps you can elaborate on that, so as to harness the power of AI and digital twinning to help it stimulate the economy, at the same time not harming the values that we stand for in terms of protection, safety, privacy. Emanuele, what are the limitations or the things we should be careful of when we look at the possibilities of AI in digital twinning today?
Thank you, Roland, and good afternoon, everybody. Can you hear me? Is it okay? Good. Okay. So we'll try to look straight, so the sound doesn't get bad. Okay. So first of all, I just want to say something on the next level of technology before going to regulation, because I think it is important also for the regulation part to understand how it's the regulation, the global regulation developing, or maybe I should say, looking at the United States in this moment at the global deregulation probably. But if we look at the next level of revolution or in technological revolution, from what we just heard, what are digital twins today and the immense opportunity that they're already offering to a manufacturing company. But today we are also at the age of a next revolution, because we are, you mentioned, Roland, the generative AI, but today we are looking at agentic AI. And agentic AI will really play a transformative role in digital twin, because I think that we will move from digital twin, fantastic tools, but passive tool for simulation. But the next level with agentic AI will be a sort of cognitive tools. So cognitive tools, it means not only simulation, but it means ability to learn and ability to take autonomous decision. And this is really a paradigm shift, I think. And also when we look at regulation and when we look at the constraints or the risk that we need to regulate, they are, completely different. So this, going back to regulation, it makes it even more difficult to regulate these technologies today, because the pace of innovation is so fast that it's almost impossible to regulate it. And then I think that also regulating technology, it's always wrong. We need to regulate the use of technologies, so the verticals. So the European approach is to develop, deploy and use technologies that are safe, that do not harm people, but that they improve the quality of people and then, of course, the quality of European industry. So this is how the principles that drove the definition of the AI Act, which was the first AI regulation, horizontal AI regulation in the world. The AI Act started, entered into force last August in 2024. So the forbidden AI system that they pose a risk that it's not acceptable for human being in Europe and everywhere. So this system, they are forbidden in Europe since this February. And among these, there are several uses. For instance, the social scoring is forbidden. The collect and use of biometrical data collected in public spaces in real time, it's forbidden in Europe, and so on. If we go to the application of digital twins or cognitive twins and the use in manufacturing, these systems, most of the systems will not have a strict regulation if they don't, if they're not used in some specific verticals, for instance, in health or in education or in critical infrastructure. In that case, they are considered high risk and they have to have a sort of certification. And the certification, it's not yet that, because this obligation will enter into force in August 2026. So the European Commission is working on this, and also the standardization body, they are working on this because they need to write the standard that then will be called harmonized standard that the companies will have to follow to be compliant with high-risk AI system. But most of these systems, the one used in manufacturing, thanks God, they are not considered high risk, but they were considered middle or low risk, and so they have some sort of smaller requirements that are on transparency, mainly on transparency. What is the most difficult part that is related to regulation and that we need to protect? Is that this system are digital systems, so as Nadir very well described, are a sort of virtual copy of a machine or a real environment. So to build this system, we need data. And to build this system into manufacturing, we need industrial data. So this data is probably the most precious thing at the moment, not only in Europe, but especially in Europe because we have lots of SMEs and because the uptake of AI in Europe is still limited. So for the next level, we need to collect this data. So we need to create a sort of data lake of industrial verticals. And the European Commission is working on this with the concept of AI factory. The AI factory, they are developing on one hand this big computing infrastructure. So we have 8 at the moment, and we have probably the biggest supercomputing in the world. And this is also what you need to train the big AI models. So next to the supercomputer, we are developing this data lake, the data that are necessary, especially industrial data, that are necessary to train this model, that are then used to run the digital twin. And then, of course, you need the funding, and these are provided by the European Commission and also by member states, but also you need the talents. And this is also one of the most researched resources at the moment, because AI talents are quite limited at the moment, and they are basically, the demand is very big. So most of them, they prefer to go and work for the big tech in the States or on big project in Asia. So this is more or less the current situation. There are lots of regulation around the world. On AI. Yesterday, actually, the Human-Centric Institute of AI of Stanford published the new AI index. I don't know if you have seen it, but it's very, very interesting. It's really sort of Bible for AI in the world. So I just had a quick look. But what they say is that there is a very high increase in the number of bills on AI that are released around the world. So if you look, for instance, at China, they already have several AI regulations. They are very strict also in the use of industrial data. If you look at Europe, as I mentioned, there is the AI Act, but we also have a Data Act that is already into force. If we look at the states, at the moment, they are more going towards a sort of deregulation. Because the previous President Biden, he issued an executive order on AI, but one of the first things that was done by Trump, among several other things, is that he canceled this executive order on AI. So at the moment, we have a sort of deregulation. I think there will be also some sort of different regulation, probably more in favor of promoting the use of AI, especially by the big tech in the States. But at the moment, the situation is quite uncertain because, as you all know, I mean, it's more focusing on trade tariff and other things.
Could you give us a concrete example of how regulations restrict the use of AI? So here's a company, they produce something, say a car company, and they want to use robots or something, and what is it they cannot do?
It depends on the risk that they pose on the fundamental rights of, in this case, for Europe, of European citizens, of the European Charter of Rights. So specifically for the car, there are some limitations, but it's more related, for instance, to the data management. So to the data they are collected to do the training of the autonomous driving cars, because when it comes to personal data, not only we have the GDPR, but the use that has to be done by an AI system is very strict. For instance, you need to make sure that the system and the data, it doesn't harm people. So not only physically, but also, I mean, psychologically, so they don't manipulate the behavior of people. So the autonomous system also of the self-driving car has to follow the same criteria. Then it has to be fair, which means that all the data that are collected and used to do the training of the algorithm, they have to be fair in the way that they don't, usually there are the bias concept related to the AI system, so that the decision that is taken in an autonomous way by the AI system doesn't cause any discrimination or cause any disequalities in the society, and this is another point. Then one of the most difficult part that probably is the most relevant, sorry, I cannot turn because then the microphone doesn't work, but it's the explicability. So what happened is that this system, probably you've heard about the black box concept. So this system, they are so complicated, so sophisticated, especially the deep learning, deep neural network, that it's almost impossible sometimes to understand how a decision is taken in an autonomous way. So if, for instance, for a car, self-driving car, there is an accident, then we don't know how the decision was taken and who is accountable, responsible for that error or mistake. So this is another important part. And the last part, which is also very important for the regulation, is the human oversight. So human beings have always to be able to substitute themselves to a decision that is taken in an autonomous way by an AI system. And this, if I think again at autonomous driving, I mean, the level 5, which, okay, in the States is there, in Europe we are testing it, but it's not there yet. It's a car without a steering wheel, which means that there is not a possibility for human being to oversight the decision taken by an AI system. And since the system that we're using today, especially when it comes to generative AI, they're not accountable, so they have a level of accountability which is not 100%. So if you think about using this system in health or even in driving, if they're not 100% safe, secure and reliable, but they hallucinate, we cannot use them, and so we need to regulate them. And this is why Europe is focusing strongly on regulation. Then we can discuss if the regulation is too much. I think it's too much, the AI Act. We need to balance regulation with innovation, and the European Commission is trying to do it, because tomorrow they will launch a new strategy called the AI continent, and there will be several measures to sort of reduce the impact of a strict AI regulation and to promote innovation.
So that's a lot about regulations. It's as if we spend more time on restricting the whole thing than on stimulating it. But I'm saying this with irony because obviously AI can lead to undesired effects, and the accountability is important. When a plane crashes and we don't know how it happened, in the end we say it was a human mistake, which is sort of acceptable. But if a plane crashes and we don't know how it happened, then we say at the end, well, it was an AI mistake, then that is not acceptable. Now, let's try to give a positive turn to this discussion by moving to our third speaker and hear from him how this power of AI and digital twinning can help us to reach our goals of sustainable development. And I would like you to distinguish between the microeconomic situation, so how companies, individual companies are coping with this. It may not always be easy, and how it helps us or can help us as a society as a whole.
And do all this in 5 minutes. Okay. So
Sure.
thank you very much, Roland. And
Yeah.
actually, I very much welcome this opportunity to connect all that we heard before about the history and how AI, digital twins have been developed, all the regulatory and very important issues. And I agree with you, we tend to over-regulate things in Europe. But again, when you play with something as powerful as this, it's good to know that it will be at the service of human society. So let me connect a little bit what manufacturing and sustainability and digital twins and AI, where the connecting point is. When we talk about manufacturing, there is a big, vast array of upstream, downstream. So you have suppliers, you have clients, you have transportation, you have logistics, you have all of that. So manufacturing this is not a simple thing. Okay, you need to have all of this value chain that is put together. And if you put on this the addition of the sustainability thing, what do you mean by sustainability? You mean energy efficiency, you mean reduction of emissions, you mean reduction of other harmful substances and other environmental harms that you can create. You mean changing materials and inputs, going to cleaner materials. You mean circular life cycle analysis, the transportation and logistics that I mentioned before, the actual security issues that are included in all this. So you also have some social aspects into all that. Now, if you try to do that in manufacturing, we have done in the past quite a lot of work with industry, and we have artificially divided this in 3 tiers. The first one, we consider design and engineering. Okay, so how you can use all these digital twins at the level of the design and engineering before you actually start producing this. Then you have the phase of construction and the manufacturing, in which you have to take all these things into account. And then you have a third level, which is equally important, which is when the goods you have produced are in operation and when they need maintenance or they need processing again when they come out of your industry. And in all of these things, I have kind of made like 10 points for each one, but I will not tire you with them, but I'll just give you some examples. Considering designing and engineering, if you want to design something that at the end of the day, at the end of its life, that it will need retrofitting, for example, you need to be able to plan for this. And to be able to plan for this, just like Nadim said, it's very important to be able to have a model that will allow you to test different scenarios. How you come to the end of life, what will it take, what the cost will be, and everything. If you don't do it, you'll probably waste a lot of money, a lot of resources, and not have the optimal result. Same kind of analysis would go if you try, for example, to incorporate more materials in which you assess the embedded carbon, how much carbon you have actually emitted in building all these materials. In all this process, when you design, you have to be very mindful of the hidden costs of all that, especially when you talk about SMEs. The hidden cost can be a matter of life or death. for whether they will be able to do it. Tons of things in design, I will not tire you more. When you come to manufacturing, the manufacturing phase, you have to look into the different solutions mix, right? So we're now talking about a continuously evolving landscape of renewable energy, cleaner energy, storage systems. They keep on changing practically every month, and you need to be able to adapt your production. And this during the manufacturing means that you have to have your data, create your model, your digital twin to be able to make the decisions. Same thing, for example, when you're trying to check the performance of your materials, right? You have to be able to measure those, or how changes might influence your lead time, the time that it will take from design to production, which is a very, very important cost thing, but also a matter of credibility of your company. So in production, you have this. And then if we go to operation of the actual goods or services that you have produced and the maintenance they may need, first of all, you have to be able to assess the energy impact from beginning to end of this thing, right? The life cycle of this thing. The digital twin will allow you to assess the overall environmental footprint of your operation, of the operation of the goods that you have done. You have to find ways to go through your models to do what we call condition-based monitoring and maintenance. So the conditions in which it will operate will change a lot how the emissions and everything will play around. And something very simple, we consider that at the end of life, we will recycle what we can, but we have had a case where we worked with industry that was producing yachting materials, like big yachts. And in those cases, we had this paradox that the end-of-life recycling was in a totally different geographical district. You produce them in Italy, you recycle them in Asia. What does this mean? You have to be able to count for all these things. So just a few examples to understand how it works, but just a final couple of words on this. I think that a strong digital environment will allow, and does already allow, and this will be increasing very fast, as we heard from both previous speakers, to be able to construct those digital twins, those scenario and analysis that you need. But you need to be able to understand it, so explainable AI, as Elisabetta said before, and then you have also to be able to visualize it. So I liked very much what Nadim said before about the metaverse level of this, because you need to be able to immerse yourself and understand. Having just a manager that sees 100 different scenarios and needs to make the discussion is a very difficult thing. So the better you develop your user interface, let's say, with these things, the better it is. And of course, the solid systems that you need for data exchange between all those points that I mentioned before are important. Now, you asked me about how it works at the micro level, and I gave you some examples of how a bigger or smaller company will do it, but think about the importance of a whole geographical region like Europe that wants and needs currently, because of what is happening geopolitically, to strengthen its SME landscape, to produce more of these kinds of examples and tools for the SMEs. This can change totally the way an industry works, and this can be very important. And then you have one more thing, which is the last thing I will tell you, which is about regulation and compliance, not in terms of how AI regulates and is compliant, but how the companies will be compliant on a number of things. So if you have to be compliant about what you report on your emissions, for example, what we're describing now, the digital twins, can be tremendously useful. Because when you try to reduce your emissions, just as an example, what this means down the road is that if you're successful, you'll have better interest rates, better insurance rates, probably, and it will cost you much less to be able to have a better result because you know how to make the decision. You don't go by trial and error. We have worked with hotels in the past, with the hospitality sector, where they had to make a choice between changing their machinery or doing better training for their maintenance people. The first to the second had a difference of 1 to 10 in terms of investment. And of course, they went for the cheaper solution and had equally good examples, but equally good results. But the important thing was to know beforehand, before you make the investment, what the result will be. And in that sense, this is hugely important. Enough. Thank you.
All right, so what we have heard today, because we're already past our time, but I will still have conclusion. There will be some time for questions. What we have seen today is that the AI digital twinning combination is a tool for companies to reduce their carbon footprint. That's one thing, but it's also a tool for governments to stimulate slash enforce the reduction of the carbon footprint. And the way Spiros tells it, it's more stimulating, but it's also enforcing. So it's always better to enforce with a carrot than with a stick. So by having a better possibility to measure sustainability in companies, individual companies, it's easier to stimulate them reach their goals. Ladies and gentlemen, we have already come at the we are close to the end of our session. Do you have any questions to the speakers? Mr. Matthew? Please, why don't you, maybe you can stand up and speak, or go to the speaker's corner. If it works.
If it does.
If it works.
It does work. I think it works. There we go.
Very well.
So really interesting talk. I'm rather intrigued because I think back to Isaac Asimov and his law of robotics. And I just quote the first bit, which is, a robot may not injure a human being or through inaction allow a human being to come to harm. So by extension, you can also take that out to looking at carbon reduction, all kinds of things. But is there anywhere legally where this description come up with Isaac Asimov back in the 1960s has actually been put into law? For example, with the EU or elsewhere. And is there a need for it, perhaps, to go into law? Thank you.
This is definitely a question for Mrs. Girardi.
Thank you for the question. So yes, I think that if we think about the European vision of AI, which is called the trustworthy human-centric AI, and it's based on three principles. The first principle is that AI developed and deployed in Europe should be lawful, so should be developed according to European law. The second one is that it has to respect the four ethical principles, of course, the ethics, the European ethics. And the last one is that it has to be robust from the technical and social point of view. And if we go to the four ethical principles, the European one, and actually are the one that I mentioned before. The first one is do not harm. The second one is to be fair, then you have the explicability, and then you have the human oversight. So these four principles, the first two, human oversight and do not harm, are exactly like Asimov's law for robotics. And today, specifically today, that we see physical AI, so we see agentic AI into robotic system, which means that we will have humanoid, not yet in Europe, but in United States and in China, we have humanoid that are able to interact, learn, adapt, and interact real time in the real world. I think that to have a law that is kind of governing this kind of interaction human-robots is very, very important today, especially for the ethical part.
Can I
Thank
add
you.
something?
Yes, definitely. You
Thank
can
you.
elaborate on that.
Nadim, you want to say something?
Go ahead, please.
No, please do.
I just wanted to add a point on how does that link to digital twins. Actually, as a matter of fact, digital twins allow to train robots and simulate how robots will operate in a factory, to be able to protect from a health and safety environment how the robot's path will be, how it will operate, what safety measures it requires to ensure that injury and loss of life does not happen. So you build this in the virtual environment, you test it in the virtual environment, and then you commission it in the real world, and that's where you can reduce significantly the impact and the hazard of it.
No, that's very useful, and actually it's a super segue because I think that there is a dividing line. What we have been discussing here is actually proposing and developing systems that are supporting humans for better decision making, practically. this is what it's all about. Once you cross this line, you go to a decision making that is not involving humans. What she was saying before, Emanuela was saying before about independent driving, for example, where humans don't even have a say what is happening. And we know that in some cases, like for autopilots in planes, actually they work better than humans without a human error. However, having said that, there is an ethical dimension and there's a political dimension, because if you come to the point of having all the decisions made that will affect how humanity lives, I should remind you, and that's the philosophical part, that what Isaac Asimov wrote many years ago, I'm a crazy fan of Isaac Asimov, by the way, was written by a human, not by a robot. And that's very important. The second thing is that, again, this was written by a human and not by the markets. And this is very important to keep in mind, because the difference between how the United States, today's United States, is regulating that and how Europe is doing it is, in the case of Europe, it's done taking into account the human values and all that, and the States is the markets. And to me, this is a super dangerous thing. That connects very much to what I said before. Thank you.
And that connects a bit to what I said about plane crashes, right? Yeah. Do we have any other questions? Yeah, I know we have already run out of time. So I'm just happy if there's no further questions. Thanks, Brian, for your question. In that case, I would like to thank our speakers for today for their useful and knowledgeable contribution to the discussion. And I would like to thank you all for coming. And then herewith, I would like to conclude the session about how DT and AI help us to reduce our carbon footprint.
And thank you very much, Roland.